3.2, key features of exponential functions. Our objective is to identify the key features of an exponential function in context of a scenario, meaning word problems. Yay! First up, some key feature vocabulary. What is the exponential form? We saw it yesterday, and it's not deleting, so I got to delete it purposely. And there it is, y equals a parentheses b to the x power. That starting point we talked about yesterday as well was our a value. The scale factor, which is the growth or decay, depending on what that value is our b value. And then some other stuff we got to make sure we talk about, because we will be doing that today, is of course our domain, which is the horizontal part, our x values, and our range, which is the vertical part, or also known as our y values. So this is all good information that we're going to be using for these problems. First up, the population of a certain bacteria can be modeled by the following equation. Y equals 10 times the quantity of 5 to the x power, where y represents the number of bacteria cells and x is the time in hours. They want us to sketch the graph for the bacteria population. Well, remember we started sketching these graphs yesterday, so there's a couple of things we need to get in order to sketch it. So first off, we're going to want to write that equation down ourselves, and then of course find our starting point, or our y-intercept. So let's go ahead and get that written down. So we're going to take this equation right here. So y equals 10 times the quantity of 5 to the x power. Again, remember, what is your a and your b value? Because that'll tell you what some key things we need to know. So our a value is going to be 10. So our y-intercept is 0, 10. And then, of course, now we got to look at our scale factor, which is 5, which that is definitely greater than 1. So we call this a growth factor. Okay, so these bacteria are growing over time. Now we need to make a little table of our x's and our y's. Again, all we need is really 3 points in order to do this. Don't forget, the y-intercept goes where? In the middle. And then we just go 1 below, 1 up, plug that in here, or do it in your head. So 10 times 5 to the -1, get that value, and then 10 times 5 to the +1 and get that value. Well, 5 to the 1 is 5 times 10, that's going to be 50. The other, you're going to want to plug in your calculator. I'm not showing that calculator work today, so you should know how to do it. If not, you better raise your hand so we can help you out. But I'm going to raise that to a -1 now, and I get a +2. So we got 2, and we got 50. Now, remember that time is in hours, so can we have a -1 hour? No. So at that point, we're not going to be able to graph, which is fine. We can graph the other two at least, though. So let's see. Well, we're not going to be able to go up to 50 here unless we count by maybe 10s here. So let's just count each of these by 10. So I'm going to put those numbers here on the left so I can graph stuff on the right. And we're going to count by 10s. And all we got to do is go up to 50 for right now. So 0, 10 right here. 150 right here. Because we're assuming that we're going to count these still by 1s. Then we can graph our function here, which is going to go skyrocketing up at a slight curve, depending on how our graph was made. Now we have that graphed. Let's now look at some questions that they're going to have us answer about it. This is that whole interpreting part and identifying part of our objective. So what is a y-intercept and what does it represent? When we found our y-intercept, it was that 0, 10. Well, we know that x represents time and y represents bacteria cells. So time is x. Well, if x is 0, let me just actually write over here. Here's our y-intercept, 0, 10. This is our x, this is our y. We need to write in words what this represents. So there's a y-intercept. We listed it. Now what does it represent? Well, in 0 hours, there are 10 bacteria. Oop, I forgot to see. Bacteria cells. There we go. Next question. Is this growth or decay, and what does it represent? Well, we've already answered that question when we were graphing it, because we wanted to find our scale factor, which was 5, which is greater than 1. So it is a growth function. So we're definitely going to write that it's growth. We can say because, growth, we don't have to ask why, there you go. Growth, and what does it represent? Represents the bacteria growing. It's growing in numbers. So I can say the bacteria is growing in numbers. There you go. I like the increasing part because that's the same thing as growth, is you're increasing. Like your growth in age or your growth in anything, you're increasing something. Now domain and range. Ah, yes, everyone's favorite thing, domain and range. And what does it represent? So let's first get off domain. Domain, I put a D, I should make that a capital D, there we go. Domain, well, domain is all your X values. So what is the beginning of time on this problem? 0, because we can start at 0 hours. And then can we just never stop? Does it say we're stopping at a certain time? No, so we're going to infinity. And I'm using that for infinity. Actually, you know what? Let me just write this out because I cannot draw infinity worth a darn. Or write it out. I can draw it out or write it out. It's a lot easier to write it in pencil than the other way, so sorry about that. Oh, earthquake there. All right, so domain is, of course, 0 to positive infinity. What does it represent? It represents hours. Our range, that's our Y values. Our Y values were the number of bacteria cells. So what do we start out with? 10. So we're going to start at 10 bacteria cells, and then if this kept going up to infinity hours, then we're going to have an infinite number of bacteria cells. All right, there's our domain and range. Now, what is the average rate of change from 2 hours to 5 hours? There's another one of your guys' favorite things you love to do, rate of change. We know rate of change is just simply slope. So these, of course, are your X values, X1 and X2. So we know these so far, 2 comma, we don't know yet, and 5 comma, we don't know yet. How do I get these messing Y values? By using the equation that they gave us, Y equals 10 times 5 to the X power. So we're going to go Y equals 10 times 5 to the second power, and we're going to go Y equals 10 times 5 to the 5th power. And then, of course, get our calculator out, do the stuff we did yesterday with that work. So we have 10 parentheses 5. We're going to square that off. We get 250. Man, after 2 hours, there's 250 bacteria. Insane. What about after 5? 10 times 5 to the 5th power is 31,250. Wow. They're just rapidly increasing, or we would say they are increasing exponentially. Ha, 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 because it's the exponential unit. All right, whatever. Slope, change in Y, so change in these values here. So 31,250 minus 250 over, well, what's our X values? The 5 and 2, the ones we have right here. Which I should probably put these numbers here. If I can write it really small. Can I do it? Can I do it? Can I do it? I did it. Yeah. Now, of course, use your calculator is what I would do. I would just actually press the big old fraction button and just put on top, what is it? 31,250 minus 250. And then on bottom, 5 minus 2. Have it computed. It's going to be a fraction still, but let's convert that because we want the rate of change. And it's going to be 10,333. We're going to round to the nearest bacteria. I'm not going to have a 0.3 of a bacteria. And this is bacteria per hour because it's a rate of change problem. There you go. Let's move on to the next scenario. Here we go. Let me blow it up. Again, same idea. The money in an investment account can be multiplied by Y equals 2,000 parentheses 1.02 to the X power. Y is the total amount of money in account. X is the time in months. Again, there's the equation we're going to use. There's what Y represents, and there's what X represents. They want us to sketch a graph. So let's go ahead and get, of course, the equation written down below so we can get our starting value as well as some other points to graph with. So it looks like our Y-intercept is right here. So our Y-intercept is going to be 0, 2,000. So then our growth factor is right here, which I'll do in blue, not red. There we go. So that means the B value is going to be 1.02. That is definitely greater than 1, just barely. So we are growing. And you hope your money's going to grow in an account that you put it in. So you're hoping that's a growth. So our graph should be going uphill. We need a table now. And this time, let's be a little bit smarter than last time. Since we know that months can't be negative, because time can never be negative. So we're going to start off at 0 months and get 1 month and 2 months out of the way. So let's go ahead and plug again these x values. We already know the y-intercept. It's 0, 2000. We just got to get 1 and 2 plugged in for x in the equation and find what it is. So this is your calculator work that you're going to want to do. And then also raise that same thing to the second power as well. Get your calculator out, and we're hoping it should be above 2,000 because we're growing money, not decreasing it. So let's go ahead and put that in. So I did my square first by accident. So I put in, it raised the second power and got 2080.8. And we're going to do that because money can be cents, and I want every cent on the dollar for that thing. And then now raise it to the 1 power, 2040. So those values right there are going to go in our table, and we're going to use those to help graph this beautiful function. That's an 8. It's really horribly an 8, but that's an 8 right there, so you know. And that's a 0, 4, 0. My numbers just don't look good. So again, we're going to look at the quadrant 1 because that's where all our positive values are. Well, since we're going as high as 20,000, well, let's see how we're going to do this one. I would probably count by 500s, which is not going to help too much here. So let's just do this. We're going to do a little break in our graph like this. And when that happens in a graph, it means you're skipping a lot of values. And then we're going to start at 2,000 here. And we're going to count by 10, 20, 30, 40, 50, 60, 70. Yeah, we can count by tens. So this would be 2010, 2020, 2030, 2040, 2050, 2060, 2070, and 2080. And then, of course, now plot those points. So 0, 2000 right here. Let's see, 1, 2040 right here. And then 2, 2000 and about 80. So we're going to go about, let's be a little above it because it's 80 cents that we're adding on it too as well. Then, of course, we're going to need to draw our beautiful line there. And then we have it sketched, and I believe there's questions for us to answer again. And sure enough, there is. What is the y-intercept? What does it represent? Well, again, we found it when we were graphing it. The y-intercept was 0, 2000. This is the x. This is the y. We know the y stands for money in the account. X stands for months. So we know that basically at the start of the account, there was $20,000. And we're going to write that in words if I can get my little thing here. There we go. So in the beginning, at the start, whatever. So, or you can say the starting. There you go. It's even better. Balance is $2,000. And that actually does represent both, because starting means a 0, 2000 means, oh, what the y is. Growth or decay, where our graph is going up, so we know that this is going to be a growth. And what does it mean? We are increasing in money. You're growing money in your account because it's growing. Grow, haha. Domain and range. Well, again, domain. Oops, we're going to write this out. Remember last time I can't draw really infinity, and we're going to assume that we're going to keep this money in forever and ever and ever because that's what you should do when you put money in an account. So for domain, it's our x values, which is our time, which is these values right here. So we start at 0 months to positive infinity months. And of course, we just said what it represents. It represents months. And then our range is going to be our y values, which we're starting at starting amount, which was a 2,000. And if we leave that money in for infinity months, then we will have infinity amount of money. Oh, and what does it represent? Well, we just said it, money in account. Oh, look, another average rate of change problem. Everyone's favorite. Okay, well, we know it's just slope. We know 3 months to 8 months are just my x values. So how much money was after 3 months? How much money was after 8 months? Well, how do we find that out? We use the equation they give us. Oops, one more zero. And then it's 1.02, and we're going to raise it first to what power? Well, we want to find out how many after 3 months. So let's get to 3 months first. So we're going to get this to 3 months, and then we're going to do the same thing, except raise it to now 4 months. 4 months, my bad, 8 months, because I really can't think. So let's go ahead and see what this is going to be. So 2,000, parentheses, 1.02, raise it a third. Again, this is a calculator work you should be doing as I'm doing it. And we get 21,022.42. And then let's look at the other one. 2,000 times 1.02 raised now to the 8th power. And if you don't know how to raise things to 8s or 3s, you better be raising your hand so we can help you out, rather than just copying what I'm writing down, because you got to know how to do this on your own. Probably be a quiz tomorrow on this. Who knows? So there's our two values. We can put them back in that point if necessary. But we're going to want to now find the slope between these 2 points. And again, I rounded them because, well, you're going to round the nearest cent. You're going to hope the bank rounds the nearest cent because you want all the money you can get from them. So now find your slope. So we're going to take the 2,343.32 and subtract it for the 2122.42 and put that all over. Of course, we're going from 8 to 3 on our x values. And then, of course, using that calculator to do all that work, which is what I do. I would press the fraction button, put the top stuff in on top. 2122.42, and then put the bottom stuff on bottom. If again you don't know how to do this, this is where you would raise your hand and ask for help. I get 44.13, and this would be dollars per, what was our units for time? Months. All right, let's continue on. It's taking a little while. Sorry about that. Here we go to the next one. Let's get this back here. There we go. Number 3, someone offers you to double the amount of money you have earned every day for 1 month, 30 days. You start with 1 dime. On the first day, you have 2 dimes. On the second day, you have 4 dimes. And then they give you the function to help find those values out. They want you to complete the table, it says. M is the amount of money after T days. Round to the nearest hundred, 2 decimals. That's because we're talking about money. Duh. So again, here's some key information. Our formula. They already give us what happened on the first day and the second day, so we can actually plug those in right now to the table. And of course, M is the amount of money after T days. So let's go ahead and get it. Well, after 1 day, we had 20 cents. After 2 days, we had 40 cents. So you can also use your calculator or just plug it in with the, I would actually use your calculator, yeah. So let's just do our calculator here. So we want to find out right here. So it's going to be y equals 0.10 times 2 to the 6th power. And this will be y equals 0.10 times 2 to the 14th power. And then I think we have more, don't we? Yep, we have y equals 0.10 times 2 to the 30th power. After 30 days, how much money would you have if you were just doubling dimes every single day? So again, I would then plug all this into my calculator, 0.10. Parentheses 2, raise that to the 6, we get 6.4, so $6.40. Now take that and raise it to the 14th power, and we get, wow, holy moly, in half the month you now have $1,638.40. Now take that to the final end of the month, the 30-month day mark. Raise that to 30, and by golly, you got a lot of money. Let's see if I can make sure I get this right. It's 107,374,182.40. So put a comma here, a comma here. There you go. 107,374,182.40. My God, that's amazing. Now they ask some questions. What does the 0.10 represent? What does the 2 represent? Well, the 0.10 represents this value right here. So it helps if we put our standard form for exponential functions right below it. What's the A value? That's your, oh yeah, your Y-intercept, your starting amount. So what does the 0.10 represent? Well, let's write in words that the 0.10 represents the starting amount, which actually is you start with 10 cents. What does the 2 represent? Well, the 2 is that scale factor. Remember, that's what you're multiplying by. Well, since I'm multiplying by 2, we're really just doubling our money, which we actually indicated up in the problem. So the 2 represents that you are doubling your money every day. Your money every day. Now, what is the average? Oh, another one. Favor those average rate changes. I love them. Okay, what's the average rate change from day 2 to day 30? I think we already did the math for those. So I think day 2 was right here, right? Yep, there's day 2. There's day 30. Let's go ahead and find our slope between those 2 points. So again, it's a change in y over the change in x, 30 minus 2. And again, I would just use my calculator for this because why not? It's big numbers. I want to work not as hard. I want to work smarter. So I press the fraction button because that's what this whole thing is, a fraction. And I would just put that top numbers in there. And then the bottom, 30 minus 2. And we're going to get this as our rate of change. And I'm going to put it down here because I need more room. And it's going to be, because we're talking about money, so dollar sign, 3834792. So put our commas here. So it looks like $3,834,792.21 per day was the rate of change between day 2 and day 30. That concludes our lesson for the day. Go ahead and do the Google slide problems to get some more perfect practice.